All right, just got to get used to the sound. So yeah, this is a talk about how we implemented high throughput logging at Spotify, or the longest incident I probably ever worked on. So some backstory, a brief and incomplete history of logging at Spotify. Back before we were running most things on GKE, everything was running in their own VMs. Things could log as much as possible to disk basically directly. As we migrated to a big multi-tenant GKE cluster setup, everything was deployed within one project. So it was a bit challenging to route logs to their actual projects that people had permissions to view their logs in. So GKE provides a managed logging agent. It was FluentD, it's now FluentBit. This runs on each GKE node, basically tails the container log files, and sends logs to the same project, which doesn't work in our case because it's a multi-tenant cluster. So you need to forward those logs from namespace foo to project foo accordingly. Otherwise, it's just a huge jumble of everyone's logs in one big project, essentially. So we were running a custom FluentD image previously with a handful of plugins built in. This was run in conjunction within a init container that maps each namespace to the host project, which solves the problem that I just mentioned. And logs were collected across namespaces, still on that single GKE node, and then forwarded to their corresponding project. So we had this Google Cloud Logging output plugin. Basically, this was a config file that had a mapping of the namespaces to the projects, and then in this config there was an n+2 amount of instances for each output plugin. So you had one to send the logs to their proper projects, depending on the namespace. You had one that just checked for this Kubernetes string and would send those to the multi-tenant project, and then you had one last output to just kind of collect whatever was left. Each instance of these output plugins had 2 threads. These threads were used to flush FluentD's internal buffer by setting the log entries to Google Cloud Logging. So this was working well at the time. But one thing we quickly learned, which is kind of like a spoiler alert, is a logging setup that works for dozens of namespaces or a few hundred namespaces doesn't necessarily work for over 1,700 namespaces as a company grows and you have a multi-tenant setup. So the incident began with a bunch of users reporting that their logs were either delayed or completely absent, depending on the node that you were deployed to. You would either completely lose your logs. Some people had some of their logs. It was a big mixed bag. A small portion of logs were getting rejected by log ingestion quotas, so that also kind of threw us off at one point because some users may have intentionally been keeping their quotas kind of low so that they didn't spend too much money on logs. Some users may have exhausted their quotas and not realized that was part of why they weren't seeing logs, but fundamentally that wasn't the main problem. So what the main problem was FluentD is limited to a single core. So many of our FluentD pods were using the single core fully and dropping logs as a result. We figured this out by basically eventually looking at this screenshot that I have here, where you can see we had 500 basically CPU cores, 500 nodes in each cluster, and then fully using basically the resources that FluentD could use. FluentD was so CPU bound in some cases that it didn't even detect that the logs were coming through, so it wasn't even seeing them at all. It didn't attempt to forward them to Google Cloud Logging, and because of this, we didn't actually know what number of logs were being lost due to CPU bottlenecks. So what do we do now? There were some solutions we had to consider. So one of them was FluentBit and multi-threading. So FluentBit ended up being the default logging agent for GKE after a certain version. That was the version we were getting up to at that point. And FluentBit was going to add multi-threading support in 1.7x. Few problems there. As we were testing out the solution, there were a bunch of versions of FluentBit that would just kind of completely go out of memory out of the bat. Another thing we learned was FluentBit is limited to 256 outputs. So before I mentioned we had 1,700 projects and namespaces at the time. That wouldn't work in this case because if you only have 256 outputs, you can't have 2 outputs for each project. And there was no timeline for when or if you would be able to have a custom FluentBit out of the box with your deployments in GKE. So that was kind of a non-starter for us. We would have to deploy FluentBit again like we were doing with FluentD and have all this custom overhead essentially. So another option we had was using Logback directly to send Java service logs directly to Google Cloud Logging. This would make the teams that owned these services responsible for their log volume and for basically like overproduction. So if logs were getting dropped, they would notice, and it would kind of be on them to check Logback. You could configure the Java services to write to Google Cloud Logging in their parent project instead of this like multi-tenant project. So it solves that like large config multi-output issue that I mentioned before. And one cool thing was you'd be able to add tracing data. Right now, we don't really have a good way to add tracing data to the logs and link them. But a few of the cons were you would need to basically create PRs and redeploy every individual service to set this up. The observability team, which is my team, would have been expected to manage the default configurations and troubleshooting for the entire company, which is a lot of overhead for like 6 people generally. And this is only a solution for Java services. So while we are mostly a Java shop, there are plenty of other services that would need logging support that we need to like figure out on an individual basis. So all that being said, what did we end up doing? We did end up with FluentBit, but we worked with Google a whole bunch to basically set up a similar version of what they do out of the box with this high throughput exporter. It's still kind of a black box to us, but it did finally work for basically everything we needed it to. So we deployed a specific version of FluentBit that ended up not running out of memory. It was kind of luck of the draw with that one. We tested a whole bunch of versions and eventually got one that didn't have some of the bugs that we saw. The high throughput exporter is just what Google uses out of the box for Kubernetes, so we deployed that on the side. This required only one FluentBit output, so all logs go through this single output through this like high throughput exporter and to their desired projects, which I'll get to a little bit later. There was improved resource allocation without like all these outputs and extra overhead essentially, so we saved a lot on resources there. We had to set up these per project log syncs in the multi-tenant project, so that's where instead of a huge output file with 1,700 different outputs per namespace and project, we have these like log syncs instead. So there are almost 2,000 of those. So this is like a high-level overview. Basically, we have the namespace to project mapping that is now loaded into Google Cloud Storage. You can see like there are nodes. Each node has this init container which handles the mapping essentially for FluentBit. All the outputs go through that exporter, and then that goes into the multi-tenant project, which then has like 2,000-ish syncs, and then those syncs will send the logs to their proper tenant project. And there's a cron job that basically like checks when new namespaces are created and makes a sync for that. So one of the problems we then ran into was this worked a little too well. As I mentioned before, we weren't sure how many logs were being dropped to begin with, and which projects were kind of logging the largest amount, depending on like which node you were on. Like I said before, some people were affected much more than others because they were next to like the really noisy projects. So we were guessing it was at least 80% of logs were being dropped at the time. For Java services, we had a little bit of a better solution where we could kind of see what percent of logs were probably being dropped and display that to teams. We had to work directly with procurement to roll this out while keeping cost under control because it was kind of crazy how much these logs blew up once we were able to support the throughput that we needed. And we got up to the test cluster and about 2/3 of production before we had to roll back the solution due to really excessive cost. So rolling back the solution after all that and after like all this time to figure this out was really frustrating. We had to basically work really closely to observe the cost data and kind of like think of a good way to fairly roll this out again and kind of like make sure things stayed under control. So what we did have now was metrics for log throughput for each project. We didn't have this before, but using like FluentBit, we had these Prometheus metrics essentially to observe log throughput per project. And then we also learned that we could set sampling on the project syncs that I mentioned. So each project sync can sample to a certain percentage. That's like an example of part of the config you add in. So we wanted to automate sampling. You're not going to like go in and add sampling to each individual project. So we created this alert in GCP that basically checks for high throughput per project. We set like a threshold, and then if you go above that threshold, it'll trigger an alert that goes into PubSub. And then PubSub is basically being looked at by the sampling service. Sampling service will then add the config I showed you before, so that will sample everything to 10%. So basically, there's not like finessing depending on what your throughput is. It's just if it's over a certain amount, you go to 10% sampling. And then the project owners are notified by email that their project has been sampled. And then Backstage, which is an open source tool developed by Spotify, we have this project log sampling page in Backstage. So it shows you like a Grafana panel of what your throughput is. And then as a result, you can like either remove the sampling, you can adjust the sampling, add more or less, whatever you want to do there. So this is kind of what that looks like. There's the alert for if you go over the threshold, or there's the Backstage changes you can make. Those both go into PubSub, and then those both go to this log sampling service. So crisis averted. With the automated sampling and a bit of finessing, we were able to roll this out again. We got to stick with the Fluent Bit-based solution, and you can see here the initial rollout had pretty excessive cost the first time around. Second time around, there was a little bit of an issue with the filters in GCP that we set up, so we had to fix that. And then by the end there, you see the cost is like significantly lower than that initial rollout was. So some of the limitations, the log syncs can't forward the logs to their actual tenant projects. They go to this default log bucket. So because all the logs are in this default log bucket, you have to do a few weird things in the GCP console where you need to navigate to a storage view. You can't use log syncs within the project themselves because it's like a sync into a sync. And you also can't use error reporting, which a few people were using. But these were kind of like smaller hangups compared to people literally not having any of their logs. So works well enough at the time. We have a bunch of feature requests open with Google to resolve some of these issues, and I think they're like almost at a point where most of this will be fixed pretty soon anyway. And as a workaround, we told a bunch of teams you can still send your logs to GCL directly, that other solution I mentioned before. At the time, we were only looking into like the Java solution, but there are a bunch of recommendations for like C#, Go, Node, PHP, etc. So if people do want to manage their own logs and forwarding them directly with Logback, they can do that as well. And I always like to end this the way I do internally as well, just logging best practices, because I think it's like helpful to always go over. But basically, like, don't just log everything for the sake of logging it. Make sure to basically just send over warning and error logs for the most part. Use tracing where you can. Use metrics where you can. And if you're really not looking at the logs and it's kind of like a test service or something smaller, just like disable logging completely if you don't really need it. Each thing has trade-offs. People really seem to love logs and want kind of like all of their logs whenever possible. So just something to keep in mind that I think people don't often think about. Yeah, and everything you log should have a purpose. I think people think logs are like free and just kind of go off into like whatever product you use to store them. But basically, there's a lot that goes into being able to like support the throughput and support the costs. So whether it's usage data, user events, application errors, and exceptions, should always be valuable to your team. Basic rule of thumb for whether to log something can be to ask yourself, is this information immediately useful in some way? And will it provide the details I need to understand the underlying cause and make decisions? And that is it.